All right, so let's get started. So, intro to linear functions. So, the first thing we're going to talk about is Jordan's problem. So, let's say Jordan is like me. He's a sneakerhead. Okay, if you don't know what a sneakerhead is, it's just somebody who loves sneakers. Okay, we love our kids, and for me, when I first got my first pair of Jordan ones, Chicago ones. That. All right. But anyway, so let's say that Jordan collects Jordans. Okay. So let's say Jordan collects Jordans. And let's say here in the year 2020, so let's say this X column right here, let's say this represents years. Okay. And then here in the year 2020, when he first starts, he has 3 pairs of Jordans. Okay. So Jordans. Okay. So in the year 2020, so he has 3 pairs of Jordans. Maybe he's got the low ones, the mid ones, and maybe he's got some threes or something like that. Okay. But he's got 3 pairs of Jordans at the beginning. Okay. Year 2020, 0. Let's say every year he collects 2 Jordans. Okay. So in year 1 or the year 2021, how many Jordans would he have? 5. Absolutely right. In the year 2022, how many Jordans would he have? In the year 2023, how many would he have? Okay. Here's your question. How many Jordans will Jordan have in the year 2070 or 50 years from now? Hold on. I'm not going to tell you. I'm not going to tell you how to do it. Here? Exactly. Right, exactly. From 0 to 3, obviously, every year he adds 2 on. He collects 2 more Jordans every year. And he doesn't give away or sell any of them. He's just collecting. So the question is, in the year 2070, how many, or 50 years from now, how many Jordans will Jordan have? Well, before you give the answer, don't shout it out. If you think you know the answer, don't shout it out yet. How could we go about figuring this out? Like, what are some ideas? Go ahead.
Well, for the X variable, it's going by ones, like 0 to 1, so it's adding 1 each time.
Okay.
Each number. So at the bottom, even though, because that says 50, I was going to say like multiply, but I don't understand how I would multiply at this point.
I agree. I think these are some definitely. I think you're thinking along the right track. I think multiplying something would probably be a good idea. Anybody else? Any other thoughts? Well, let me ask. Does anybody think they know the answer to this? Yes. It is. How did you figure that out? Okay. Right. Right. Exactly. So let me repeat what you said. So you said the years, they're going up by 1 each time. And every year, so every year, since he gets 2 Jordans, then you just said, okay, well, it's 50 years. So you just do 50 times 2, which gives you 100, but he started with 3, so the answer must be 103. That's what you said, right? Absolutely correct. And this is something that I definitely would think about and think about doing it this way as well. One of the ways that I've seen it done is somebody could say, okay, well, he starts with, so year 1 or year 0, he just starts with 3. And then the next year, it's 3 plus 2, right? Because he got 2 Jordans that year. And then the next year would be kind of like 3 plus 2 plus 2. And then the next year would be 3 plus 2 plus 2 plus 2. You all see how this is going, right? So basically what you can say is, hey, I'm going to have 3 plus 2, and then repeated addition is just multiplication, right? And it's going to be 2 times whatever year I'm at. So you see there are 3 2s for year 3, 2 2s for year 2. Does that make sense? So you could say year 4 would be 4 times 3 plus 2 times 4. Or you could say year 50 should be 3 plus 50 or 2. I'm sorry. 50 should be 2 times 50. Does that make sense? Because it's kind of the same thought process here. All of these are absolutely correct in the way that we are thinking about them. As a matter of fact, we can create a formula based on this idea. So let's break down the different parts of this formula. And there's a very famous formula that I'm sure you all have seen. You might have seen it before. You might not have. It's called y equals mx plus b. Have you seen it? Maybe you have, kind of. I think pretty much everybody's seen this. I'm sure some of y'all hate this thing. Y'all saw it so many times, you just get tired of it. But let's talk about what this is in relation to Jordan's problem. All right, so let's start with y. Y, this is merely my outcome. It's my outcome. Like, this is how, or you can think about this as your output, right? This is your dependent variable. More importantly, this number is based on what I put in, right? So like I put in 0 years, I get 3 Jordans. I put in 2 years, I get 7 Jordans. So think about this as our output. And I'm just going to put y down here because I'm actually going to create the actual equation. Now, what is m? Well, m stands for slope, which is the same thing as, and I want you all to start thinking about slope as rate. Okay? In other countries, it's called the gradient. I'm sure you're not really going to see that too much in algebra, but rate is what we use more often than anything else. Rate. What's his rate? Well, a rate is something per something. What's a very famous rate when it comes to like driving? What rate do we use a lot? Miles per hour is what I was thinking of. Like, what's your speed? Speed is a rate. It's 60 miles per hour, 70 miles per hour. And think about it like this. If I'm going 60 miles per hour and I drive for 2 hours, how many miles have I driven? 120. How'd y'all figure that out? 60 times 2. Notice you multiply the rate times how many hours you were going in that case. Does that make sense? That's why you have m times x, because you're going to multiply your rate times how many years in this case, right? So if you think about it, and so in this point, y was Jordan's, our outcome was Jordan's. In this case, our slope is going to be Jordans per year. As a matter of fact, it's 2 Jordans per year. Does that make sense? That's my rate. It's 2 Jordans per year. So I could put it down here as just 2, right? So that's my rate. My rate is 2 Jordans for every 1 year. All right? 2 Jordans for every 1 year. My y value goes up by 2 for every 1 year. Think about this as, I'm sure you've seen this, rise over run. In other words, rise stands for how many Jordans am I getting, which is 2, for every, what time period are we talking about? 1 year. Does that make sense? So I'm doing 2 over 1 or just 2. I'm getting 2 Jordans per year. 2 Jordans per year. Now, of course, X, that just stands for my years, okay? All right, that's my, and this is, of course, my input in this case. So we just leave it as X. But then there's one more piece of the pie that we need. There's one more piece of the pie. Do I start off with 0 Jordans? No. How many Jordans do I start with? 3. So since I'm starting off with 3 Jordans, we could call this my initial point or something like that, or also known as the y-intercept. Why is it known as the y-intercept? Because it's saying, where do I start? Where am I starting from? Am I starting from 0? Am I starting from 3? Am I starting from negative 15? You know what I'm saying? B stands for my initial point. In this case, where did we start from? When X was 0, where did we start from? 3. So that's why the formula or the equation for this scenario would be y equals 2x plus 3. We're saying the amount of Jordans that I have is based off the 2 Jordans per year, okay? The 2 Jordans per year, but I start with 3. Do y'all see how this sentence reads? Does this kind of make sense as to why this works? Okay, great. Awesome. All right. So this right here is this is the equation, the linear equation for this scenario with the Jordans. All right. Everybody got that? Good? Okay. So that said, another way we can think about this, let me erase this here. Another way we can think about this equation is just as a function. Okay. So let's kind of go back to our thinking about our factory here. In this case, remember, and I'm just going to just draw a couple of that table again. So we had like 0, 3, 1, 5, and so on and so forth. Okay. So here's what I want you to think about our factory. So our function is denoted by f of x. Okay. And f of x equals 2x plus 3. I want you to go ahead and write that down. So we got this scenario. Remember the factory, right? Something goes in the factory, something comes out. So if I put 1 into my factory, okay, what happens? I get what out based on my XY chart? 5. I get 5 out. Do y'all see that? When I put 1 into my factory, I got 5 out. Does that make sense? Okay, that said, let's see what happens in terms of the algebraic part. If you take 1 and stick it in here, we denote that as f of 1. Do y'all see that? All I did was replace this x here with 1 because I'm saying my input to my function is 1. Y'all follow me so far? So f of 1 would be 2 times 1 plus 3. Does that make sense? Okay, because we're saying that I'm inputting, my input is 1. So then, that of course, 2 times 1 is 2. I mean, after this is easy, right? 2 plus 3 is 5. So then the output is 5. Does that make sense? All right. So let's go back to our original problem. What if I input 50 into my function? Exactly. And let's prove that that's true. F of 50 equals 2 times 50 plus 3. Y'all following me so far? So then that gives you 2 times 50 is 100 plus 3, or like we said it would be 103. So our output is 103. Does that make sense? All right. Now, f of x and y, these are two values that pretty much, or two variables that are pretty much interchangeable for the most part. Okay. So if you see y, then you could replace it with f of x. If you see f of x, you could probably replace it with y. Does that make sense? Okay. All right. So let's talk about evaluating these functions for a second. All right. So we kind of talked about it a little bit, but I want to do just a little bit more practice here. So I want you to write, so let's say f of x equals x plus 6. As a matter of fact, let's make this x squared plus 6. We'll come back to linear in a minute, but let's say it's x squared plus 6. Okay. And let's say I want to figure out what happens when f is -2. All right. I want to find f of -2. What you do is you take the -2, and wherever x was in your equation, you're going to replace that x now with -2. So you would have something like this: -2 squared plus 6. Does that make sense? Then -2 squared, obviously that's -2 times -2. Negative times negative is positive, so you got 4. 4 plus 6, that gives you 10. So this would be my answer. If I said evaluate f of -2, then f of -2 would be 10. Let's say I had g of x equals negative x cubed minus 12 plus x squared. Okay, and now you're like, oh my goodness, don't worry about it. It's still going to be, it's still the same thing. Let's say if I said, what is g of 2? What is g of 2? Well, once again, everywhere there was an x, I now replace with 2. Does that make sense? So now I'm going to have negative 2 cubed minus 12 plus 2 squared. This then gives me -8, right? 2 times 2 is 4. 4 times 2 is 8. Minus 12 plus 2 times 2 is 4, so 2 squared is 4. -8 minus 12 is -20, plus 4 is -16. So the answer is -16. So that's how you evaluate these functions. Now, how do you tell if something is linear? How do you tell if something is linear? In other words, what linear does is it has a very distinct pattern. So let's see if we could graph just for a second. Let's see if we can graph Jordan's problem. Okay, so make a little quick graph here, and I'm gonna focus mainly on the positive side. Okay, but obviously we can deal with the negative side as well. So let's see if we can graph this. So obviously here we've got the x-axis here, we got the y-axis here. I'm sure you all are familiar with graphing. And let's say this 1, 2, 3, 4. I know this is not exact, but you're gonna get you get the idea. 4, and so on and so forth. Okay. So we got 1, 2, so 1, 2, 3, 4, 5. Okay. 6, 7, maybe. And maybe 3 out here. Okay. So the first thing we want to do is when graphing, okay, there's 3 things you want to do. The first thing that you want to do is graph the y-intercept. Okay, so when you're graphing, the first thing you want to put down is what is the y-intercept. Remember, that's my b value from y equals mx plus b. So in this case, how many Jordans did Jordan start with? 3. So the first thing that you're going to graph is a point right at 0, 3. Right? Once again, the ordered pair is 0, 3. Remember, this represents at 0 years, he had 3 Jordans. Okay, so 0, 3. Then what you do is we're going to use the slope to graph the next point. All right. So remember, slope is rise over run. Okay. Slope is rise over run, which in this case is 2 over 1. So in other words, we're going to go up 2 and over 1. Does that make sense? So you're going to go up 2. So 1, 2, and then over to the right 1. So that's going to be a point 1, 5. And then you would do it again. Go up 2 and over 1. And then you're just going to draw a line connecting the dots. And of course, it goes probably in both directions. This is linear. Why does it create this line? Yes. No, go ahead. No, you had your hand up. Right. It's a straight line. That's what makes it linear. Absolutely correct. And it is a straight line because the slope is constant. In other words, forever and always, we will always get 2 Jordans every single year. Does that make sense? So it's always going to be plus 2, always plus 2, always plus 2. Like, if you made, $100 an hour, which would be, that'd be nice, wouldn't it? All right, you made $100 an hour, every hour, you're going to make $100. If you made $100 one hour, then you made $50 another hour, then you made $2 the next hour. Anybody have an idea of a business or a anything that actually does do that, where you could get paid $100 in 1 hour and then $2 the next hour, maybe even negative $200 the next hour? Any Apple? Like you like about like Apple stocks? I mean, for the most part, they pay their people pretty well. But what I want to think, what other professions? What did you all say? Okay. I was thinking stockbrokers. That's kind of what I was thinking, but I agree with some of the things that you all were saying. Now, is it linear? How do I determine if this is linear? This is the last thing I'm saying. We'll be done for the day. How do I determine if it's linear? Let's say that you have this XY plot, and let's say I've got 0, 1, 2, 3, 4, and so on and so forth. And let's say it's 0, 5, 1, 10, 2, 15, 3, 20. What is the next one going to be? 25. How'd you figure that out? Yeah, I'm adding by, yeah, exactly. The x-axis, I'm adding by 1. Here, I'm clearly adding by 5 each time. This is definitely linear, right? It means I'm doing the same thing each and every time, all right? It's like I'm getting paid $5 an hour. So this is how much money I'm making every hour I'm working. Does that make sense? Now, check this out. What if you have something like this? Can you tell me what comes next? I mean, you could guess that it was maybe 16 or something like that. But let's say then I told you it was 2 was the next one. And then the next output was 14. Would this be linear? No, this isn't linear. Why? Because right, the slope isn't constant. So I changed my rate was 1 here, and then my rate here was 3, and then my rate here was 5, and then my rate here was 7. Even though you could kind of tell what was going on, the rate itself wasn't constant, was it? All right, so if the rate's not constant, in other words, constant is the exact same, then it's not linear. Questions? All right, that's pretty much it, y'all.